This is why we refuse to explain why magnets work. People often ask a very reasonable question. Why do magnets work? They want an explanation, a neat one, something solid, something they can hold in their hands and say, ah, now I understand. But here's the trouble. When we rush to explain why, we often replace understanding with vocabulary. You can say, magnets attract because of magnetic fields, but that's not an explanation. That's just giving the mystery a name. If I told you that magnets work because of invisible lines in space that pull on each other, you might nod politely, but ask yourself honestly, do you now understand magnets? Or did you just trade confusion for comfort? Real science doesn't fear confusion. It respects it. At some point, every explanation hits bedrock. Why do charges attract? Why does space behave this way? Why does nature choose these rules and not others? And the truthful answer, the brave answer is, we don't know why, we know how. We can measure it, we can predict it, we can use it to build motors, generators, computers, and entire civilizations. But when we pretend we know why, when we invent stories just to make ourselves feel satisfied, we stop learning. Refusing to explain why magnets work is not arrogance, it's honesty. It's saying, I will not lie to you with pretty words. I will not destroy your curiosity with fake certainty. I will not replace wonder with slogans. Because wonder is the engine of education. The moment you think you fully understand something, you stop asking questions. And the moment you stop asking questions, progress ends. So when we refuse to explain why magnets work, we're not giving up. We're standing guard at the edge of knowledge saying, this mystery is still alive, don't kill it. And that refusal, that respect for the unknown, is exactly what has always pushed humanity forward. Not answers, but better questions. When people ask why magnets work, they are often not really asking for science, but for reassurance, for a story that feels complete. And the problem is that real education is not about making people feel comfortable. It is about helping them see clearly, even when the view is unfinished. We can describe magnets with great precision. We can talk about fields filling space, forces acting at a distance, moving charges giving rise to measurable effects, equations that predict exactly how strong the pull will be and where it will point. And all of that is solid, tested knowledge. But the moment we say this is why magnets work and stop there, we commit a quiet intellectual mistake, because what we have really done is replace one mystery with another that sounds more official. Saying magnetic fields feels explanatory only because we are used to the words. Yet those fields are just as strange as the attraction itself, invisible structures that somehow exist everywhere and somehow influence matter without being matter at all. If we try to push deeper and ask why fields exist, we find ourselves explaining them in terms of even more fundamental ideas. And those ideas rest on assumptions we cannot explain either. At some point, the chain of why questions must stop, not because curiosity has failed, but because nature simply presents us with rules, not reasons. This is not a weakness of science. It is one of its greatest strengths, because science refuses to invent comforting stories where evidence runs out. Education at its best teaches students to recognize this boundary and to respect it. The refusal to explain why magnets work is really a refusal to lie, a refusal to dress ignorance in confident language and call it understanding. True understanding comes from knowing exactly what we know, how we know it, and where our knowledge ends. When students learn that magnets obey certain laws, that those laws can be tested, challenged, refined, and used to build real technologies, they gain something far more valuable than a fake explanation. They gain trust in the process of thinking itself. Mystery does not weaken learning, it fuels it. The unanswered why is not a dead end, but an open door, inviting deeper questions, better experiments, and more careful reasoning. History shows that progress is made not by people who accept tidy explanations, but by those who are bothered by the gaps, who notice that saying a word is not the same as understanding a phenomenon. When we teach magnets honestly, we are also teaching intellectual courage, the courage to say, this is how it behaves, this is what we can measure, and this is where our explanations stop for now. Or that honesty trains the mind to resist oversimplification in every field, not just physics. It teaches that knowledge is not a collection of answers, but a living structure built on evidence, uncertainty, and constant questioning. By refusing to explain why magnets work, we protect the most important lesson education can offer. That reality is under no obligation to be simple, and that the pursuit of truth is not about closing questions, but about learning how to live productively, creatively, and rigorously with the unknown. We can measure it. We can predict it. We can use it to build motors, generators, computers, and entire civilizations. But when we pretend we know why, when we invent stories just to make ourselves feel satisfied, we stop learning. Refusing to explain why magnets work is not arrogance. It's honesty. It's saying, I will not lie to you with pretty words. I will not destroy your curiosity with fake certainty. I will not replace wonder with slogans, because wonder is the engine of education. The moment you think you fully understand something, you stop asking questions. And the moment you stop asking questions, progress ends. So when we refuse to explain why magnets work, we're not giving up. We're standing guard at the edge of knowledge, saying, this mystery is still alive. Don't kill it. And that refusal, that respect for the unknown, is exactly what has always pushed humanity forward. Not answers, but better questions. When people ask why magnets work, what they usually want is not a scientific account, but a sense of closure, a feeling that the mystery has been neatly wrapped up and put away. And education often fails when it pretends that this desire can always be satisfied. We can explain magnets in terms of magnetic fields, electric charges in motion, and mathematical laws that predict forces with astonishing accuracy. And all of this is real powerful knowledge. Yet the moment we claim that this explains why magnets work, we quietly cross from honesty into storytelling. A magnetic field sounds like an explanation only because it is familiar language, but it is not less mysterious than the attraction it describes. It is an abstract entity that fills space, has direction and strength, and influences matter without being visible or tangible. If we press further and ask why such fields exist at all, we find ourselves resting on deeper principles that are simply observed facts about nature, not conclusions derived from something more fundamental. Every explanation ends somewhere, and pretending otherwise teaches students the wrong lesson. That science is about confidently answering every question, rather than carefully distinguishing between what is known, what is inferred, and what remains unexplained. True education trains the mind to see that knowing how something behaves and being able to predict that behavior reliably is already an extraordinary achievement, even if the ultimate why remains out of reach. By refusing to invent final answers, science preserves its credibility and its power. This refusal is not a failure of imagination, but an act of intellectual discipline, and it carries an important motivational lesson. When students are told a shallow explanation and encouraged to stop thinking, curiosity withers. When they are shown the limits of understanding honestly, curiosity survives and grows. The mystery of magnets is not a gap to be embarrassed about, but a reminder that nature does not owe us intuitive explanations that fit everyday experience. Instead, it offers patterns, regularities, and laws that can be tested and used, and it challenges us to accept that deep reality may not resemble the stories we tell ourselves. Learning to live with unanswered questions is not a weakness. It is a skill, and a crucial one for any serious thinker. Progress in science has always come from people who were dissatisfied with easy answers, who noticed that naming a phenomenon is not the same as understanding it, and who were willing to sit with confusion long enough to ask better questions. When we teach magnets honestly, we teach something larger than physics. We teach respect for evidence, humility before the unknown, and confidence in the process of inquiry rather than in final conclusions. Refusing to explain why magnets work is really a way of saying that education is not about closing doors, but about keeping them open. Not about replacing wonder with certainty, but about using wonder as fuel for deeper thinking. In that sense, the mystery is not a problem to be solved away. It is the very thing that keeps learning alive and moving forward. We can measure it, we can predict it, we can use it to build motors, generators, computers, and entire civilizations. But when we pretend we know why, when we invent stories just to make ourselves feel satisfied, we stop learning. Refusing to explain why magnets work is not arrogance, it's honesty. It's saying, I will not lie to you with pretty words. I will not destroy your curiosity with fake certainty. I will not replace wonder with slogans, because wonder is the engine of education. The moment you think you fully understand something, you stop asking questions. And the moment you stop asking questions, progress ends. So when we refuse to explain why magnets work, we're not giving up. We're standing guard at the edge of knowledge, saying, this mystery is still alive. Don't kill it. And that refusal, that respect for the unknown, is exactly what has always pushed humanity forward. Not answers, but better questions. When people ask why magnets work, they are usually asking for a kind of explanation that feels complete and satisfying, something that makes the phenomenon seem familiar and ordinary, but education becomes misleading when it pretends that such explanations always exist. We can describe magnets in terms of magnetic fields, forces, equations, and measurable effects, and these descriptions are extraordinarily successful at predicting what will happen in real situations. We can calculate how strong the attraction will be, how it changes with distance, and how it interacts with electric currents, and these predictions work every time we test them. Yet none of this truly answers the deep why question people think they are asking. Saying that magnets work because of magnetic fields only shifts the mystery to a new place, because the field itself is an abstract concept that cannot be seen or touched and must be accepted as part of how nature behaves. If we ask why fields exist, we are pushed toward even more fundamental ideas, and those ideas rest on observations rather than deeper explanations. At some point, the chain of reasoning stops, not because science has failed, but because science is honest about where explanation turns into description. Teaching this distinction is crucial because it shows students that understanding is not about memorizing words, but about knowing what claims are supported by evidence and where certainty ends. This honesty is often uncomfortable because it resists the temptation to provide simple stories that make the world feel intuitive. Human intuition evolved for throwing stones and judging distances, not for understanding invisible forces acting across empty space. So it is no surprise that magnetism feels strange. Education does real damage when it tries to smooth over that strangeness with oversimplified explanations that sound satisfying but say very little. When students are told such stories, they may feel temporarily confident, but they have not learned how science actually works. Real scientific thinking involves accepting that some things are known only through their effects, that we build models to describe patterns, and that those models are judged by how well they match reality, not by how comfortable they feel. The refusal to explain why magnets work in a final story-like way is therefore a form of respect for the learner and for the subject itself. It invites students to grapple with the idea that nature operates according to rules that are not required to match everyday intuition, and that understanding often means becoming comfortable with abstraction. This approach does not reduce motivation. It strengthens it because it encourages learners to ask sharper questions and to distinguish between what is assumed, what is measured, and what is still unknown. Living with unanswered questions is not a weakness in education, but one of its most valuable outcomes. The history of scientific progress shows that advances come from people who notice the gaps, who are bothered by explanations that only rename the problem, and who are willing to admit ignorance without losing confidence. When students learn that magnets work according to reliable laws, but that the ultimate reason for those laws remains unknown, they are learning a broader lesson about knowledge itself. They learn that certainty comes from careful testing, not from confident language, and that mystery is not an enemy of understanding, but its companion. This mindset trains people to think critically in every area, to resist easy answers, and to value precision over comfort. By refusing to explain why magnets work in a simplistic way, education preserves curiosity instead of extinguishing it, and curiosity is the engine that drives learning forward. The unanswered why becomes an invitation rather than a failure, pointing toward deeper inquiry and reminding us that reality is richer than our explanations. In this sense, the mystery of magnets is not something to be eliminated, but something to be protected, because it teaches that the goal of learning is not to end questions, but to learn how to ask better ones and to pursue them with honesty, rigor, and wonder. We can measure it. We can predict it. We can use it to build motors, generators, computers, and entire civilizations. But when we pretend we know why, When we invent stories just to make ourselves feel satisfied, we stop learning. Refusing to explain why magnets work is not arrogance. It's honesty. It's saying, I will not lie to you with pretty words. I will not destroy your curiosity with fake certainty. I will not replace wonder with slogans. Because wonder is the engine of education. The moment you think you fully understand something, you stop asking questions. And the moment you stop asking questions, progress ends. So when we refuse to explain why magnets work, we're not giving up. We're standing guard at the edge of knowledge, saying, this mystery is still alive. Don't kill it. And that refusal, that respect for the unknown, is exactly what has always pushed humanity forward. Not answers, but better questions. When people ask why magnets work, they often imagine that somewhere there exists a simple final sentence that will dissolve the mystery and make the phenomenon feel ordinary. But education becomes misleading the moment it pretends that such a sentence is possible. We can explain magnetism in terms of carefully tested laws, mathematical relationships, and models that describe how forces behave in space. And these explanations are incredibly successful in practice. They allow us to design machines, generate electricity, store information, and predict outcomes with remarkable precision. Yet none of this truly answers the deeper why that people instinctively mean. When we say magnets work because of magnetic fields, we have not uncovered a hidden cause. We have introduced a concept that summarizes observed behavior. The field itself is not an explanation in the everyday sense, but a tool for organizing measurements and predictions. If we push further and ask why the field exists, we eventually arrive at principles that are accepted because they match experiments, not because they can be reduced to something more familiar. Education becomes powerful when it makes this clear, because it teaches students to recognize the difference between describing how nature behaves and claiming to know the ultimate reasons behind it. This distinction matters because language can easily create the illusion of understanding. A well-chosen word or a confident definition can make a mystery feel solved even when nothing new has been learned. In science, this illusion is dangerous because it encourages people to stop questioning too early. Magnetism is strange, not because it is poorly understood, but because it does not fit neatly into everyday intuition. Invisible influences acting across empty space challenge the way we expect the world to behave, and no amount of storytelling can remove that strangeness without distorting the truth. When education respects this discomfort instead of hiding it, students learn something deeper than facts. They learn how scientific knowledge is built. They see that models are judged by their accuracy and usefulness, not by how satisfying they sound, and that explanations are always provisional, resting on assumptions that could one day be replaced by better ones. Refusing to offer a final why is not evasive, it is an honest acknowledgement of how far understanding currently goes. This honesty plays a crucial motivational role. When learners are given shallow explanations and told there is nothing more to ask, curiosity fades because the subject appears closed and complete. When learners are shown the edge of knowledge and invited to look over it, curiosity intensifies. The mystery of magnets becomes a reminder that there are still questions worth pursuing, that even familiar objects can point toward deep and unresolved problems. This perspective teaches intellectual humility without discouragement. It shows that not knowing everything is not a failure but a normal and productive state, and that progress comes from clearly identifying what is unknown rather than pretending it has already been solved. Students trained in this way become more careful thinkers, less satisfied with slogans, and more willing to examine the foundations of what they are told. They learn to value evidence over authority and clarity over comfort, skills that extend far beyond physics. In the end, refusing to explain why magnets work in a simplistic way is a defense of education itself. It protects learning from becoming a collection of memorized answers and preserves it as an active process of inquiry. By acknowledging the limits of explanation, education teaches respect for reality as it is, not as we wish it to be. Magnets, quietly pulling and pushing without revealing their ultimate reasons, become a lesson in how knowledge actually functions. Reliable but incomplete, powerful yet open-ended. The unanswered why is not an embarrassment but an invitation. signaling that understanding is something we approach, refine, and deepen over time rather than something we possess once and for all. When learners absorb this lesson, they are better prepared to think critically, to tolerate uncertainty, and to remain curious in the face of complexity. In that sense, the mystery of magnets is not a problem to eliminate, but a valuable teacher, showing that the true goal of education is not to silence questions, but to learn how to ask them honestly and pursue them with patience, rigor, and wonder. We can measure it, we can predict it, we can use it to build motors, generators, computers, and entire civilizations. But when we pretend we know why, when we invent stories just to make ourselves feel satisfied, we stop learning. Refusing to explain why magnets work is not arrogance. It's honesty. It's saying, I will not lie to you with pretty words. I will not destroy your curiosity with fake certainty. I will not replace wonder with slogans, because wonder is the engine of education. The moment you think you fully understand something, you stop asking questions. And the moment you stop asking questions, progress ends. So when we refuse to explain why magnets work, we're not giving up. We're standing guard at the edge of knowledge, saying this mystery is still alive. Don't kill it. And that refusal, that respect for the unknown, is exactly what has always pushed humanity forward. Not answers, but better questions. When people ask why magnets work, they often believe that somewhere there exists a final, simple explanation that will make the phenomenon feel obvious. But education becomes misleading when it encourages that belief. We can describe magnetism with impressive accuracy using laws, equations, and models that tell us exactly how magnets behave in different situations. We know how the force changes with distance, how it interacts with electric currents, and how it can be harnessed for practical use. These descriptions are powerful because they work every time they are tested, yet they do not answer the deeper why people think they are asking. Saying that magnets work because of magnetic fields feels like an explanation, but it is really a translation of observation into technical language. The field is not something we see or touch. It is a concept that helps us organize what we measure. When education treats such concepts as final answers, it risks confusing familiarity with understanding and replacing curiosity with vocabulary. If we try to push past this and ask why magnetic fields exist at all, we discover that every explanation rests on something that must simply be accepted as a feature of nature. We can move from fields to more fundamental theories, and from those to even deeper principles, but eventually we reach statements that are not explained by anything more basic. They are supported by experiment, not by deeper reasoning. This is not a failure of science, but a reflection of its honesty. Science does not promise ultimate reasons. It promises reliable descriptions of how the world behaves. Education becomes stronger when it makes this clear, because students learn that knowledge is built on evidence and testing, not on comforting stories. Understanding then becomes the ability to navigate what is known and unknown with clarity, rather than the illusion that everything has been neatly resolved. The temptation to offer simple explanations is strong, because human intuition craves familiarity. Invisible forces acting through empty space feel unnatural, and it is tempting to smooth that discomfort away with metaphors that sound satisfying. But such metaphors can quietly damage learning if they are mistaken for truth. When students are given explanations that feel complete but are not precise, they may stop questioning too early. Real understanding often feels uncomfortable because it requires accepting abstraction and uncertainty. Magnetism does not behave the way everyday objects behave, and no story can make it do so without distorting reality. By refusing to oversimplify, education teaches respect for the subject and for the learner's ability to handle complexity. It shows that clarity is not the same as simplicity, and that good explanations often reveal how strange the world really is. This refusal also has a powerful motivational effect. When learners are shown only finished answers, learning appears closed and static, as if all the important questions have already been settled. When learners are shown the limits of explanation, learning becomes dynamic and alive. The mystery of magnets then serves as an invitation rather than a frustration. It demonstrates that even well-understood phenomena still contain deep questions, and that curiosity is not a sign of ignorance, but a driving force, behind progress. Students who are taught this way learn to value questions as much as answers. They become more careful thinkers, less impressed by confident language, and more interested in how knowledge is justified. This mindset prepares them not just to absorb information, but to evaluate it critically and extend it further. Ultimately, refusing to explain why magnets work in a simplistic way is a defense of intellectual integrity. It acknowledges that reality does not owe us intuitive explanations, and that understanding is an ongoing process rather than a finished product. Magnets quietly demonstrate that the world can be predictable without being fully explained, and that mystery can coexist with usefulness. By learning to accept this, students gain a deeper appreciation for how knowledge actually functions. They learn that certainty comes from evidence, not from the absence of questions, and that admitting the limits of understanding is a strength rather than a weakness. In this way, the mystery of magnetism becomes more than a topic in physics. It becomes a lesson in how to think, how to remain curious, and how to pursue truth without pretending that it is ever complete. We can measure it, we can predict it, we can use it to build motors, generators, computers, and entire civilizations. But when we pretend we know why, when we invent stories just to make ourselves feel satisfied, we stop learning. Refusing to explain why magnets work is not arrogance, it's honesty. It's saying, I will not lie to you with pretty words. I will not destroy your curiosity with fake certainty. I will not replace wonder with slogans. Because wonder is the engine of education. The moment you think you fully understand something, you stop asking questions. And the moment you stop asking questions, progress ends. So when we refuse to explain why magnets work, we're not giving up. We're standing guard at the edge of knowledge, saying, this mystery is still alive. Don't kill it. And that refusal, that respect for the unknown, is exactly what has always pushed humanity forward. Not answers, but better questions.